Okay. Okay, so this is the first of the distance measures that I mentioned, the edit distance. Now there is a more complicated variant of the edit distance called the weighted edit distance. Now the weighted edit distance is defined similar to the edit distance that we saw last time, except that the weights of the insertion, deletion and substitution operations could be different. Okay, that's one part of the difference. So last time we saw that the edit distance was totally measured in terms of the number of operations, and it didn't matter whether the operation was an insertion operation or a deletion operation or a substitution operation, because each operation was treated as with a cost of 1. But now we are saying that the cost of the different operations could be different, and moreover, even when talking about a single operation like insertion, the cost of um, or let's take substitution, not insertion, sorry. Even when talking about a single operation like substitution, the cost of substituting one character by another character is not going to be the same for uh, a given pair of different characters. The weights for substitution will be defined based on how likely it is that somebody could mistype one character for another character. So recall that in the context of optical character recognition, uh, we saw that there are certain kinds of errors that are more likely. Like O, for example, can be mistyped or misspelled as a D. So in that case, the weight for substituting an O with a D is going to be small. Remember that these weights correspond to costs of that particular operation. So the cost of substituting an M by an O by a D is going to be smaller than the cost for substituting an O with an I. And what you're trying to do is you're trying to minimize the weighted edit distance, right? Which is defined as, and the way you calculate the cost is by summing up the cost of every operation during that transformation. And the cost of every operation is going to depend on the type of operation it is, as well as what are the specific characters that you are substituting with other characters in case of the substitution operation. For the keyboard, in the same way, because M and N are located right next to one another, it's more likely that you will mistype an M with an N than mistyping an M with a Q, because Q is pretty far away on the keyboard. So the cost of substituting an M with an N or vice versa is going to be smaller than the cost of substituting an M with a Q. Right? So we can build some kind of a probability model, or think of it more as a cost matrix. So a cost matrix tells you the cost of substituting any character by any other character. So we have all the characters here from A to Z, and also other kinds of characters if necessary. And the ith row, jth column of this cost matrix is the cost of substituting this character, whatever this character is, with this character. Okay, and note that all these costs could be different. Right, so we will use this cost matrix in that dynamic programming algorithm instead of, so what was the cost matrix in the last class? It was a matrix where all these costs are equal to 1 for the substitution operation, and for the insertion operation and deletion operation also the cost was 1. Whereas now we are saying that the cost of an insertion or a deletion could be different from a cost for a substitution, and the cost for a substitution could be given by an entire matrix, because it's going to depend on what are the two characters that you are substituting. Okay, so this weight matrix or a cost matrix is needed by the dynamic programming algorithm, and we can modify that algorithm pretty simply in order to handle these weights. Does anybody want to take a guess as to what will be the modification in the algorithm? How would you modify the algorithm we discussed last time to incorporate this weight matrix and these different costs? It's a very direct modification. In case you forgot what the, yeah,
Hello, sir. We could probably replace the S over there by another function, that A function which we just made, Aij, by the cost matrix. S of
okay,
I comma
yeah,
could become Aij.
yeah. So instead of S being a 1, if the two are the same, then the cost will be 0 as before. But if the two characters are not the same, then this S is going to be a function of what this particular character xm is and what this particular character yn is, and this will just be a lookup into the cost matrix. Like what other changes?
Sir, I think that would be enough. I mean, if in the cost matrix, I A of I would, if you just store it as 0, I think that should be enough. Right.
Yeah, that's right. I mean, you can think of this as being incorporated directly into the cost matrix, where the diagonals of the along the diagonal of the matrix you have the cost of 0. What other modifications would you need for the algorithm to work as before? Any other modification that's needed?
Okay, sir, I'm just guessing it. Should we multiply the weights with the E of m minus 1 into comma n minus 1?
Why would you want to multiply the weights with, you mean these weights?
No, sir, we have different weights for different operations.
Yeah.
So
So those are the weights given by, so the different weights are given by the value of this particular function S. So this is nothing but a lookup into the weight matrix. In the xm, in the row corresponding to xm and in the column corresponding to yn, the weight that is stored in that particular cell of the matrix is what you will put here.
okay, sir.
The other modification that's needed is that instead of a 1 here, you will have the cost of an insertion and the cost of a deletion. Yeah, and that need not be 1. It could be something different. Depending on how likely an insertion or a deletion operation is compared to these substitution operations. And again, this is something that will need to be empirically determined, based on a lot of study of how users mistype queries. You'll need to take data in order to figure out what these weights are. You need to figure out the probability of each of these operations and accordingly assign weights. So that's the modification to the Levenstein distance or the simple edit distance algorithm that we saw last time. Okay, so we've seen two of the distance measures now. Could you please turn off the microphone since I'm hearing some echo? Yeah, thank you. So let's now look at something called an n-gram overlap, which is another way to measure how close a particular word is to another word. But before we look at that, just to just as a motivation to introduce the idea of an n-gram overlap, let's first try to work with the distance measure we've defined, which is the edit distance or the weighted edit distance, and see how we can do spelling correction using these distance measures. Now suppose you're given the query. One way you could come up with proposed corrected spellings for that query is to enumerate all the strings that are within a particular edit distance from that query. So let's say I decide that the set of possible correct terms of which my query term could be, a bad spelling, is going to be at a distance of at most 1 from this query term. In that case, I would enumerate all character sequences or all strings that are at a distance of 1 from this query term. And then I would see how many of those strings are present in the lexicon, which tells me what the correct words are. And then if multiple of them are found in the lexicon, I will choose the one which has the maximum or the highest collection frequency. Recall that collection frequency is the number of times a particular term is found in the corpus as a whole. And stop words have the highest collection frequency. So if there are two strings that are at the same edit distance from the query, we will choose the string that has a higher collection frequency. And by doing that, we can get a sorted list of potential corrections to the query, and then we can show them to the user, and we can ask the user, did you mean any of these? Okay, so the basic idea here is start from the query and look at all the strings that are at a distance of 1, or you can define the threshold as 2 from the query. For each of those strings, check whether those strings check whether that string is found in the dictionary or not, in the lexicon. And if it is found in the lexicon, note what its collection frequency is in the dictionary, and come up with this ranked list of spelling corrections. Now this part of the slide pertains to the question that was initially asked, which is how exactly do we decide whether or not we want to do a spelling correction? And if we want to do a spelling correction, how exactly should we go about presenting a good UI to the user? I think we also saw this last time where I showed you how Wikipedia presents its spelling correction, how Google presents its spelling correction. The two were different because if you remember from last class, we saw that in Wikipedia, the spelling, the corrected spelling is just proposed and no results are returned as such. So that is something you have to decide. What sort of interface do you want to present to the user? Okay, one possibility is that we could look up all the possible corrections in the index. Okay, that means you take every single corrected word that is ranked over here and look at all the documents containing each of those words. Okay, maybe the highest ranked term will correspond to 10 documents. So you will first present those 10 documents to the user. Then the next set of results will be the results for the second term in that ranked list, and so on. So you could present all possible corrections to the user. Now this is going to be very slow because for every corrected word or every candidate corrected word, you're going to query the index, extract the list of documents for that particular term for the post from the postings list of that particular term, and then you're going to take an OR operation here and then return all the documents. So that's pretty expensive. That's one way you could go about doing this. Alternatively, you could just take the term that is ranked highest. You look at what is the best candidate for spelling correction and just return the documents for that best candidate. Now, the advantage of this is that the user, you're returning the results directly to the user. The user doesn't have to do anything here. But the problem is that the user is disempowered here because the user has no say on what exactly he or she wanted. Maybe the term that you, maybe the documents you came up with did not correspond to the actual spelling. So the other thing that you could do is you could, the other extreme is don't return any documents. Simply ask the user, did you mean this particular word? Or you can present 3 words, perhaps, just like Wikipedia, and allow the user to click on one of them. And then you present the documents corresponding to that particular clicked term. So that way you're empowering the user more, but then it's going to require an extra round of interaction with the user. And that's something many users may not like. And what we saw last time was Google combines both these extremes into a hybrid scheme where it will also ask you whether you meant this particular term, and if you actually did mean that particular term, it's also going to present the documents for that corrected spelling to you. Right? And if you did not mean that particular term, you could click on one of the alternatives and then you would get what you were looking for. Okay, so there's a variety of approaches here that you can think of. Let me actually take a simple example over here. So I'm deliberately going to look up a term that is very rare. Okay, I'm going to take up a Sanskrit term, in fact. Now, clearly I'm using an English search engine, right? So I don't expect many documents to match with this particular term because this is not really an English term. But some documents may have a transliterated version of this term. But look what I get in the results. I don't get any document which has this exact term. Instead, I get about 126,000 results for the closest term in the lexicon that Google came up with as probably the term that most likely was what I intended. Okay, but it's also providing me the option that if I did mean that original string, okay, then I could click on this, and now I'm going to get only documents which have that particular term. Now notice how many results I get. I get about 493 results for this original query term. And that was one of the ways in which Google decided to do spelling correction, because if there are only 493 documents on the web that have my query term, it's very likely that I probably misspelled the query. And that is why Google does this spelling correction automatically. Okay, now I'm going to use a term that is slightly more common in Sanskrit, so there should be more documents. Now you can see that there are about 8,600 results returned, and now I'm getting the documents which have that particular term, at least approximately. This is not really a good result, but based on whatever tokenization or linguistic preprocessing Google does, I'm returned a bunch of documents which actually have this term. But note that I'm also offered an alternative. I'm offered, so Google asked me, did you mean this particular term? That means Google did do a spelling correction. It did run its spelling corrector here. Why did it run? Because 8,600 is still not good enough. But it's larger than 493. 493 is too small. So what Google did was the documents that it returned over here corresponded to the corrected spelling term, to the corrected spelling. Whereas here I am being shown documents for my original query term, but I'm asked whether I meant something else. So the likelihood that I misspelled is low, but it's still large enough that Google is running its spelling correction algorithm and asking me whether I meant this. And if I click on this, you can see that I'm getting about 1.8 million results. Now let's search for a query that's very, very common. It's just Amitabh. Now this has about 21.4 million results. Okay. And do you see any proposed spelling corrections? No. Why? Because if there are 21.4 million results for this particular query, it's likely that I did spell the query term correctly because I got so many results. Right? So you note the difference between these three particular terms that I queried. Okay. Do you see how Google treats these three terms differently? Because the number of matches it finds for these three terms falls in three different ranges, and so it adopts three different approaches for spelling correction and the UI also for dealing with that particular query term from a UI perspective. Any questions about this?
Sir, excuse me. Can you hear me, sir?
Yeah, I can
Sir,
hear you.
for checking the probability, that is the likelihood output for the spelling correction, because it is taking dynamically, because the result is coming dynamically. So how the spelling correction is made, because the corpus is stored and all the steps, all the phases are covered before coming out with the result, or only the last phase is done for bringing out the result. Because for all these different queries,
Mhm.
it has to go to different phases. That is the pre-phases of what we have discussed so far. So how does the Google handle this different phases? Because the rank could change today, or based on the time, the rank or the likelihood of a particular word can change. So is how exactly
Uh,
it is?
no, so the rank, are you asking about the cost matrix? Whether that could
Yes,
change? Yeah,
yes, yes.
the cost matrix would be fixed. It would be something that would be computed based on past queries. So Google will maintain a huge query log. They have a log of all the queries, and based on looking at the query logs, they would, figure out, and based on the known spelling mistakes, they would look at a huge number of known spelling mistakes and then compute what was the
See, on
likelihood
the
of
run,
one.
it is doing all these things, all the phases, the pre-cost calculation as well as predicting retrieving the relevant result.
No, the cost calculation would be done only periodically. I don't know how frequently they do it, but it would be done
Oh,
it would be done very occasionally just for setting the cost matrix. And once that matrix is set, then that matrix would be looked up for doing spelling correction. It won't change. It will change
okay,
only, I mean, if at all it changes, it's going to change very, very occasionally.
okay, okay,
Because it's not very likely that, there's no need to dynamically compute this if the probabilities are relatively stable.
okay,
And the
okay,
probabilities will be relatively stable if the sample size of the data is large enough. If they are looking at a huge number of queries, then they already know what the distribution of those different spelling errors is, or those substitution error probabilities are. And those probabilities are not going to change with more data because they
thank you,
you know
sir.
as, yeah.
Yes, thank you.